All right, students, today we're looking at distinguishable permutations. So what does distinguishable mean? Distinguishable means we can tell things apart. So if we want to take a look at what that would mean, if I had something that looked like a star, flower, happy face, and a snowflake, those are all distinguishable. They're all the same. They're all different from one another. Okay? So if we were looking at different ways to put these in order, we could tell what all these are apart from one another. They're distinguishable. Okay? We are going to take a look at permutations that are non-distinguishable tomorrow. Or not tomorrow, because tomorrow's our project day, but the next class. The next lesson that we do will be on non-distinguishable permutations. So we've already done a little bit of this, but we're going to figure out what 6 pick 2 is and 5 pick 5 is. And again, we could use the formula or we can just use the graphing calculator. If we use the graphing calculator for 6 pick 2, we hit 6, then we go to the math menu, we pick the probability menu, and then we pick option 2, and then we write a 2 for 6 pick 2, hit enter, and the answer is 30. So going here, the answer is 30. We don't need to show any work, okay? What if it was 5 pick 5? Well, we go back to the calculator, we go 5, math menu, probability, option 2, 5, hit enter, and we see that 5 pick 5 is 120. So again, we can work within the formula, or we can just use the calculator to figure out what 6 pick 2 or 5 pick 5 is. Okay? Now let's do a couple examples. First one. In order to access a website, Robert must choose a 4-digit number, a 5-digit number, or a 6-digit number. Just one of those. It could be a 4-digit number, a 5-digit number, or a 6-digit number. But he cannot choose the same digit twice in his number. How many different numbers could Robert choose? So we have to figure out the number of 4-digit numbers, the number of 5-digit numbers, and the number of 6-digit numbers. Okay? So if we think of the 4-digit numbers, how many ways can Robert choose the first digit of the 4-digit number? It's 10. How many ways could he choose the second digit of his 4-digit number? 9. How many ways can Robert pick the third digit of his 10-digit number? 8. And how many ways could Robert pick the fourth digit in his 4-digit number? 7. So, to figure out the number of 4-digit numbers that Robert could choose from, we would take 10 times 9 times 8 times 7. And we should get 5,040. Is that what we get? Okay. So we get 5,040 4-digit numbers. Now we answered that question using a diagram. Okay? But what we could also do is we could use permutations. So if we go to our graphing calculator and we go 10, because there's 10 digits, 0 through 9, we go to the math menu and we go to permutations, which is option 2, and go 10, pick 4, hit enter. What do we get? 5,040. Looks familiar, hey? Because that's what we found when we figured out 10 times 9 times 8 times 7. So in other words, 10 times 9 times 8 times 7 is equivalent to 10 pick 4. So if I was to ask you for the number of 5-digit numbers Robert could pick, how would we find that using permutations and the graphing calculator? Ten pick 5, right. So we can go 10 pick 5 to find the number of 5-digit numbers he could pick. So 10, math menu, permutation, 5 equals, the number of 5-digit numbers Robert could pick is 30,240. So for 5-digit, we don't have to show our work. We can just say 10 pick 5, which is 30,240. So we can write it out pictorially like we did for 4-digit numbers, or we can use permutations like we did for 5-digit numbers. They're both doing the same thing. So how do we find out how many 6-digit numbers Robert could use? Ten pick 6. I'm willing to bet that 10 pick 6 would be 151,120. Is that good? Or am I off? 200. Okay, so I am off a touch. So we'll fix it up. So that's the number of 6-digit numbers Robert can pick. Now the key thing about this question is that we know the number of 4-digit numbers he could choose. So that's 5,040. We then know the number of 5-digit numbers he could choose. That's 30,240. And we know the number of 6-digit numbers he can choose, which is 151,200. Now what we need to do though, since he can choose 4-digit numbers, 5-digit numbers, or 6-digit numbers, we can add those numbers up together, and that gives us the total number of passcodes he could use. So we got to add those together to get the total number of passcodes he can choose from. So that's 5,040 plus 30,240 plus 151,200 which should give us 186,480. Is that what you guys got? Okay, so that's the number of passcodes Robert could pick, given that he can use a 4, 5, or 6-digit passcode, understanding that all those passcodes are no repeating numbers. So if you use a 7, you can't use a 7 anywhere else in the passcode. Okay? In probability and in just counting things, when we think about the word or, Like he can have a 4-digit code or a 5-digit code or a 6-digit code, or implies that we're going to add the results together. Okay, the word or means that we add the results together. So we take the number of 4-digit numbers, add them to the number of 5-digit numbers, and add them to the 6-digit numbers. Okay? All right. Flip the page and we'll do one more example. No, Mika's also a boy. Mika's named after my favorite Calgary Flames goaltender. So, yes, I have 5 dogs: Abby, Mika, Sam, Sophie, and Gracie. How many ways can the dogs have their picture taken in a line if, part A, Sam, Sophie, and Gracie are all beside one another? Okay? So how do we do that? Well, when we have a question like this, when we have things in a line, and we want things to be together, what we have to do is think of the things that we're having together, so that's Sam, Sophie, and Gracie, and pretend like they are one unit. They are one unit, okay? So they're one unit. So if the 3 dogs are one unit, how many units are there all together? No, there's only 3, because the 3 dogs count as one, and then we still have 2 left over. Okay, so I'm actually going to draw that out so it's a little bit clearer. So we have Sam, Gracie, and Sophie, and we're considering that as one dog. And then we'll say we have like Abby and Mika. Okay, so really what we're doing is we want to find the number of ways of arranging those 3 units. So to arrange 3 units, it would just be 3 factorial. Okay, so for part A, it would be 3 factorial. And we could actually map out every single one of those outcomes because it's not very many. We could have Abby first, Sam, Gracie, Sophie second, Mika third. We could have Abby first, Mika second, Sam, Gracie, Sophie third. Okay. Now, there's no other combinations where Abby's first, so let's put Sam, Gracie, Sophie first, Abby second, Mika third, and then Sam, Gracie, Sophie, Mika second, Abby third. And likewise, who have we not put first yet? Mika. So Mika's going first, and then we can have Sam, Gracie, Sophie second, Abby third, and Mika first, Abby second, and then Sam, Gracie, Sophie third. Now, by doing that, you might say, hey, there are 6 ways of doing this because we have 6 combinations, right? 1, 2, 3, 4, 5, 6. And you'd be right to a certain extent. One of the things that said at the beginning of part A was this: Sam, Sophie, and Gracie have to all be together. So that did not tell us in what order Sam, Sophie, and Gracie would be arranged. Okay? So what we've basically done so far is we've looked at how the grouping of Sam, Sophie, and Gracie would be arranged with Abby and Mika. And we found that there's 6 outcomes, or 3 factorial. So there's 3 factorial ways of arranging Sam, Sophie, and Gracie with the other 2 dogs. But we still have to consider the number of ways of arranging Sam, Sophie, and Gracie. So Sam, Sophie, and Gracie are how many dogs? 3. So how many ways are there of ranging of Sam, Sophie, and Gracie? Just those 3, right? But how many ways are there just arranging of Sam, Sophie, and Gracie? Yeah. And how would we get that using the, you're right, you're absolutely right, but how would we get 6 using the terminology that we've learned in this unit? What is equal to 6? Beautiful, 3 times 2 times 1, or 3 factorial, right? So there are 3 factorial ways of arranging Abby, Mika, and the group. But there's also 3 factorial ways of arranging Sam, Sophie, and Gracie within each of those groups. So to figure out the number of ways of arranging all 5 dogs, given that Sam, Sophie, and Gracie are all together, is 3 factorial times 3 factorial. And since 3 factorial is 6, it's 6 times 6. So therefore, there's 36 ways of arranging Sam, Sophie, and Gracie with Abby and Mika, given that the 3 dogs have to be together. Okay? So that's part A. And once you understand how to do this, you don't have to do any of this, the cases that we did. You could just jump right down to 3 factorial times 3 factorial equals 36. You don't have to show any of this work. I'm just showing where that comes from. Okay? So that's part A. Part B says, I think Gracie does not want to be in the middle. Now that's a little bit more straightforward. If Gracie doesn't want to be in the middle, then we know that we have 5 dogs lined up, okay? And we know that Gracie does not want to go in the middle. So how many dogs can we put in the middle? 4. All we know is that Gracie doesn't want to go in the middle. So therefore, 4 dogs can go in the middle. Once we've placed one of those dogs in the middle, how many ways could a dog go in the first spot? Right, because we've placed one here in the middle, so there's still 4 left. And how many dogs would there be to go in the second position? 3. And how many dogs would there be go in the position to the right of the middle? 2. And how many ways would there be for a dog to go in the last position on the right? 1. So in other words, it's 4, the 4 in the middle, times 4 factorial to figure out the number of ways to arrange the dogs if Gracie will not go in the middle. So 4 factorial is 24. 4 times 4 factorial is 96. So there's 96 ways of arranging the dogs if Gracie does not want to go in the middle. Okay? All right, now we'll do part C. Part C, Abby and Sophie don't want to be beside one another. This one's similar to A. A was the 3 dogs do want to be together. C is the dogs don't want to be together. So to figure out this question, what we have to consider first of all is how many ways we can arrange the dogs if there's no restrictions. So we have 5 dogs, we want to line them up for a photo, there's no restrictions. How many ways can we do it? 5 factorial. So the number of total ways, so the number of lineups with no restrictions is equal to 5 factorial or 120. So that's the number of ways of doing it if there's no restrictions. Now you might ask why we care about that in this question. But basically in this question, we are going to go about this a little sneaky. Instead of figuring out directly how many ways they don't want to be together, we are actually going to find out the number of ways that they are together. And then we're going to subtract that from the total number of ways. Because if they can be together like 30 ways, well, then they're not together the remaining 90 ways, right? So if they're together, then we consider the two of them as one dog. And we still have the other 3 dogs to place. So if we want to figure out the number of ways that they are together, using what we did in part A, can you give me an expression that would help us find the number of ways that they would be together? More. I want more. Because you're telling me 4 factorial. 4 factorial is the number of ways of arranging these. No. We'll get there. We still have to arrange these 2 dogs. How do you arrange, how can you arrange 2 dogs? What's that? Okay, let me ask you this question. Yes, you're right, but how would you arrange 7 dogs? 7 factorial. How do we arrange 5 dogs? 5 factorial. So we arrange 2 dogs in 2 factorial ways. Okay? So we have to arrange this 4 factorial ways, and we're also going to multiply that by 2 factorial because that's the number of ways of arranging Abby and Sophie within each of those groupings. Okay? So 2 factorial is 2, 4 factorial is 24, so altogether there's 48 ways of arranging them when they are together. So we now have to find out in how many ways are they not together. And to figure out the number of ways that they're not together, we're going to take that 120 that we found at the beginning of this part of the question and subtract 48. And when we do that, we get 72 ways that they are not together. Okay? So are we clear why it's 4 factorial, 2 factorial? Are you good with that, Sky? Okay, good. The homework for this is on pages 255 to 257. It's numbers 1 to 18. There will be a quiz on this, but tomorrow's a project day, so the quiz will not be until Monday's class, okay?